Hello everyone, my name is Rayyan Khan studying Masters in Construction Management at Nottingham Trent University. Today I'll be talking about the tallest green skyscraper, that is Shanghai Tower. The 632 meters tall Shanghai Tower, designed by the American architectural firm Gensler, sits on a 30,370 square meters plot, which is located in Luozhi Finance and Trade Zone, Pudong District, Shanghai. This 127-story high-rise is a mixed-use mega-tall building with retail, office, hotel, observation deck, and restaurant. Shanghai Tower's construction started on November of 2008, topped out in 2013, and was opened to public by the summer of 2015. Shanghai Tower is the second tallest building in the world after Burj Khalifa in Dubai and the tallest in China. It is also the first Chinese super high-rise that exceeds 600 meters. It cost around 2.38 billion US dollars. Many stakeholders from all around the globe were brought together in order to get this mega structure together. For every small work or job, a consultant or a contractor was appointed to keep the workflow smooth. The site area of Shanghai Tower is 30,370 square meters, which incorporates 5-floor podium area. The tower stands at 632-meter high with 127 floors above ground and 5 floors below ground, which includes 2,000 car parking spaces. Building's total construction area is 576,000 square meters, above ground floor area of 410,000 square meters, and underground construction area is 166,000 square meters. As a green building, a full 33% of this site is green space with landscaping that breathes fresh air into the city and shades paved areas that radiate heat. Soil conditions in Shanghai is a clay-based mixture typical of a river delta. Thus, Shanghai Tower construction site sits on a soft soil rich in clay. Due to tower's dimension, weight, and unfavorable soil conditions, a very complex foundation system was required. Engineering team decided placing 955 reinforced concrete board piles, that is 1 meter in diameter, to deep into ground, then continuously poured 61,000 cubic meters of concrete to create the 6-meter thick mat slab foundation. This foundation mat serves as the bottom platform of the main tower. The piled raft foundation is in the shape of an octagon. Shanghai also has a windy climate and it is an active earthquake zone. Structural team was facing amount of challenges. The structural engineers sought to simplify the building structure system with a 90 by 90 foot concrete core. Due to Shanghai Tower's geometry gradually narrows at each floor level, consequently, the concrete core section reduces and gets simpler in Zone 5 and Zone 7. The lateral and vertical resistance of the tower will be provided by the inner cylindrical tower. The primary lateral resistance is provided by the core, outrigger, and super column system. Shanghai Tower is a high performance building, hence many kind of high performance materials were selected for this mega tall. Different grades of concrete was used in different zones and different components of the structure. The lateral and vertical resistance of the tower will be provided by the inner cylindrical tower. The primary lateral resistance is provided by the core, outrigger, and super column system. This system is supplemented by a mega frame consisting of all the super columns, including the diagonal columns, together with a double belt truss at each zone that picks up the intermediate steel columns in each zone and the mechanical and refuge floors at the interface of the adjacent zones. Shanghai Tower is a high-performance building, hence many kind of high-performance materials were selected for this mega-tall structure. The Q345GJ steel used by the outrigger trusses, belt trusses, and ring radial trusses provided strength for the entire tower. Shanghai Tower's scale and complexity have created so many firsts for China's construction industry, but the structure design itself and beam made for an easier and faster construction process. Workers positioned rebar and poured the mat foundation in March 2010. They affix steel for the super columns through the summer, and by the December 2010, the structure core was taking shape. Shanghai Tower has a very unique design, a soft vertical spiral rotating at about 120 degrees, scaling at 55% rate exponentially, and a double skin facade. Gensler team anticipated that three important design strategies that will be adopted are the asymmetry of the tower's form, its tapering profile, and the rounded corners would allow the building to withstand typhoon wind forces that is common in Shanghai. A large number of structures now being designed, especially very tall buildings, should always consider the relationship between importance of wind and building height. For designing Shanghai Tower, Gensler conducted a series of wind tunnel tests at RWDI for understanding the building performance and defining the optimal shape of the exterior skin of asymmetrical tapered tower that reducing wind load, consequently using a lighter, more efficient structure that conserves natural resources. To establish the best possible case for reducing these loads, several scenarios were proposed involving the rotation at 90 degrees, 120 degrees, 150 degrees, 180 degrees, and 210 degrees, and then scaling of 25%, 40%, 55%, 70%, and 85%. All these scenarios were analyzed against each other and then compared to the base case scenario. As seen in the table, wind tunnel test pinpointed that the most beneficial scaling factor of about 55% and rotation at 120 degrees, which is account for 24% saving of the wind load working on the structure as compared to base case tapered box. This equates that 50 million US dollars in saving in the building structure alone. Shanghai Tower is one of the most sustainably advanced tall buildings in the world designed to achieve both LEED Gold certification and a China Green Building 3-star rating. After defining the optimal shape of the exterior curtain wall by using wind tunnel testing, the entire building is wrapped by two layers of transparent skins with a complex curtain wall support system. The outer skin, that is curtain wall A, gradually narrows at each floor level, giving the glass tower an elegant tapered profile, while a V notch in the curtain wall accentuates the spiraling geometry. The shape of the inner skin curtain wall B is cylindrical due to the interior curtain wall's geometry circular and two-dimensional, which requires 11.4% less glass than a building occupying the same total floor area but in a square design. At the interface of the adjacent zones, a two-story full floor area is created strategically to house mechanical, electrical, and plumbing equipments to provide optimal flexibility, reduce operation costs, and conserve energy. This area also serves as the respective zone's life safety refuge area. This floor platform creates a base for the atrium spaces directly above. Sustainability is at the core of Shanghai Tower's development. In addition to Shanghai Tower's peculiar height and unique architectural style, design team incorporated many other strategies that will generate a positive environmental impact. Ground source heat pump or geothermal heat pump system exchanges heat between the constant temperatures of soil and the building to maintain the comfort temperature of the interior space. Because the underground soil temperature is relatively stable throughout the year, higher than the ambient air temperature in winter and lower than the ambient air temperature in summer. Therefore, ground source heat pump system is suitable for both heating and cooling. Air conditioning with ice thermal storage is green, cost-effective and reliable solution for cooling offices, schools, malls, convention centers and other buildings with daily comfort cooling requirements. During off-peak hours, ice is made and stored inside ice storage tanks. The stored ice is then used to cool the building occupants the next day. Following are the reasons for using this advanced air conditioning system in order to save energy. A conventional electrical power is produced by inefficient process. A fossil fuel such as oil, coal, or natural gas is burnt in a giant furnace to release heat energy. The heat is used to boil water and make steam. The steam drives a turbine The turbine drives a generator and the generator makes electricity. The simultaneous generation from a single fuel source makes combined cooling, heat, and power system highly efficient compared to conventional power generation and making it the ideal solution for organizations which have significant cooling requirements. Super tall and mega tall buildings are ideal for wind power because of abundant wind resources on top of the buildings all year round. Hence, Shanghai Tower Design team has chosen this renewable energy. This energy produced by wind turbines is rectified by the inverter and converted, which then goes to the substation later to the building electrical power supply network. In order to meet the requirements of the National Green Building 3-star standard, the non-traditional water resource utilization ratio of functional areas should not be less than 25% of Shanghai Tower Hotel. Non-traditional water resource utilization ratios of businesses offices should not be less than 40%. Following are the processes of treatment. Elevator is one of the largest energy consuming equipments of high-rise buildings. Elevator Association of China estimates that the average daily power consumption of each elevator is around 40 kilowatts per hour, about 5% of the total building energy consumption. The working of the elevator with regenerative drive system is when the carriage travels down, the motor acts as a generator, transforming mechanical power into electrical power and pumping current back into the facility's electrical grid to use elsewhere. There are 106 elevators in Shanghai Tower. Few of those are double deck elevators. The real benefit of the double deck elevator is that while people can be transported in the same time as single deck elevators, the required shaft area is reduced. Shanghai Tower has three super high speed double deck elevators that are capable of traveling at 18 meters per second, four double deck elevators traveling at 10 meters per second, and five single deck elevators traveling at 8 meters per second. The unique design and extraordinary complex structure of Shanghai Tower have brought unprecedented challenges and created so many firsts of China's construction industry, but beam made for an easier, securer, and faster construction process. Beam technology has ensured construction safety, quality, and fast progress of a complex curtain wall system of Shanghai Tower. In order to preserve natural resources and lower the negative influences of construction on the surrounding environment, the Sustainable Construction Management was implemented to Shanghai Tower. The construction monitoring and management data shows that the measures to control dust, noise, and light pollution are effective and meet the requirements of Chinese green. The Shanghai Tower is not the tallest building, but it is the tallest green skyscraper in the world. Thank you. Building label standard.